Hello engineers, today and I'm going to be giving a tutorial on how to navigate in 3D space using GPS coordinates as a compass. There are compass mods out there, but usually they are for when you are in gravity and they are for two-dimensional navigation. Because generally speaking, elevation is not that big of a deal when you're navigating in Space Engineers. So here we are in space. This is a vanilla star system, and we'll be talking about navigation here, and I'll be creating GPS coordinates and walking through why I'm doing it this way. So when we are in space, reference points are difficult because you can't use the sun because the sun is revolving around you. You can use planets, but their position changes as you move around the star system. So I'm going to start by creating the GPS points, and then we'll go over why I have them. So I'm basically just going to hit new and start by creating my first GPS coordinate. I like to use the nav script or nav prefix when I'm making these. Start with up, down, east, west, north, and south. Gotta spell south. There we go. Okay, so these coordinates, I'm going to go ahead and give them some color so that way we can differentiate them easier when we use them as actual GPS coordinates. Make that one yellow. And usually I try to use bright colors because that can help see them. We'll make one kind of light purple. There we go. Blue. That's the only one to have blue. Okay, so we have our coordinates, and right now they're all going to be at system center, which is Earth-like. So now what we want to do is we want to create the extreme distances of north, south, east, and west, which is going to be X, Y, and Z. Okay, so up and down are going to be Z. So we go to up and we create our first coordinate. Basically all I'm doing is I'm spamming ones and zeros, and it's going to get us some point many light years away if I put enough zeros in there. So I'm going to control C that, and this will be a positive Z because this goes up. If you're not sure what I'm talking about, go ahead and pause this and Google what three-dimensional space is, and kind of look at a graphing calculator and how that determines what X, Y, and Z is on a graph. So there's up, and then we can go to Z, and we want to make that down. And that's going to be negative because it's going down. Except I have to make sure, a little trick when you're doing this is do Control A, that way you're selecting all of it, and Control V so you're not getting some weird value that Space Engineers is going to yell at you over. Okay, so east and west is left and right, and that's going to be X axis. Okay, so let's go east is going to be to the right, so that's positive. So Control A, Control V. And then west is negative, so bring it over here and put negative. And north and south is going to be Y, and that's positive. And then south, which is behind us, is negative. Make sure to press enter each time you put the value in these so that way it saves for sure. Okay, we're going to go ahead and make sure that these are all always visible to make it easier for ourselves when we talk about what we're going to do. Alright, so if I did this right, here we go. So basically what we're doing is we're taking a graph of X and Y, and we're pushing it to the floor. And that is now our floor, is X is going up, and X is going forward and behind us. Y is going west to the left and east to the right. That is our floor. And then you put a flagpole right in the middle of it, going up and going down, and that's our Z. So to orient ourselves, we'll go ahead and look at north, and that's forward. And you can see all the GPS coordinates around our map. All we have to do is spin, so that way east is on the left and west is on the right. I screwed that up. East is on the right, west is on the left. So that way if you're looking at a globe, and you've got the north and south pole, right? East and west, and there you go. So now we have X and Y as our plane that we're standing on, and then we have up and we have down. So now we have reference points that we can navigate in space. All right. So if you're doing fleet maneuvers, you can have the fleet, we're all oriented the same direction, we're all oriented north or whatever, it doesn't matter. You can say, hey, B-wing, navigate to the east 50 kilometers, or go up, or whatever, doesn't matter. Basically, everybody has a common reference points that they can point at and go to it. The reason why this works is because space engineers' maps are generally very limited in their scale. They're going to be maybe a couple thousand kilometers across. The largest I've ever seen is 100,000 kilometers even. Doesn't matter, it could be 1,000,000 kilometers, because if you put the points out far enough, relative to you, they are not going to move, because the angle of direction is so tiny, they might as well be still. Basically creating for yourself north stars in 6 directions. If you want to park yourself in space, you say, hey, go to this point of, this is for Draconis Expanse specifically, go to this point in the belt and go down 200 kilometers. That makes it easy. So you'd be like, hey, get at least 600 kilometers away from Ceres, and then go up or down 200 kilometers. With this system, you can tell somebody that, and they'll know exactly what you're saying, and they can put themselves where you directed them to go to. Or you can navigate around instances. In Nexus, there are multiple servers within one server, and you can actually use this system to make sure that you are missing something. Because if Earth, like, is right there, right, and I want to get around that, you can use the cardinal directions to get yourself around that bubble. Alright, so we talked about XYZ planes. For advanced maneuvers with a fleet, you can use any one of these points to orient yourself and then change the directions. Anybody who's ever read Ender's Game, the enemy's gate is down, right? All the fleet commander has to do is say, hey, the enemy is down. East and west are our new floor. So now down and up, east and west are now the floor. So now up and down has become south and north, just depending on, so that way if you know the general direction of the enemy, you can pick that direction, and that's now the new floor. One of the things that you can do as a fleet commander is you can use the 3Ds. Start with direction, distance, and description. So you say, hey, enemy to the north, 20 kilometers, massive signature, or threat level 8, whatever. And from there you can give direction to your fleet on what to do. A wing, B wing, etc. and give them coordination. Fleet maneuvers. This portion of the tutorial is specifically on how to orient your fleet to make giving orders a little easier. So you've determined where the enemy is coming from. We'll make it easy to start with enemy to the north, 100 kilometer signature. So everybody orient to the north, And the standard operating procedure, or SOP, will be have west to your left and east to your right. That way you know where to orient your ship and where to point. The reason why this is important is so that way everybody is uh, facing their guns the right way. That's pretty much it, really. You pick your direction, and there you go. Anybody who has read the game, the book Ender's Game, knows the little phrase, the enemy gate is down, right? So you can literally have down and then have west and east again as your left and right, but now north and south, you're looking up and down, right? And it's just where to point. That way you know right away. So if the fleet commander says, hey, flank left, B-wing, you know that you can move your cursor to the left every time. And that's why this is important, is having a standard operating procedure of how to orient your ship so that way you are not confused which way is where. Because if you just turn your ship wherever and he says west and you're used to it being off to the left, you'd be like, shit, oh, okay, it's that way. It can help reduce reaction times and make coordinations a little smoother. So fleet orientation, pick a direction, and have a standard way of which direction is which way. Even if you don't establish a standard direction, the system still works because you turn the fleet where you need to go and you can tell people, hey, go west, and then they'll just turn to the west because they see it on their screen. So this is a optional but fine-tuning way of how to run a fleet. You can also do that with fixed points, like let's say Earth-like here. Hey, Earth-like is now the new point of reference. It's a little more tricky, but you can say, hey, that's our point of direction, and then you can tell people to go north or go east or whatever, go south. That gives you a better sense of where you need to tell people to go. You can even take it even more advanced and be like, hey, go north by west and split the difference. Hey, go that direction, right? You're going to split the difference between the two and go that way. It gets in, you can get as convoluted as you want, depending on how well trained your guys are. And that's pretty much it. So you create the GPS points, and then you now have a method to navigate, to direct fleets, to coordinate, and tell people where to go. And that's it for now. You have a wonderful day.